Hey, what's up guys? This is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 170 Computer Systems and Networks. In this lecturette, I'm going to show you how to use the QTSPIM simulator. I'm also going to show you some common errors that programmers run into when they start coding in MIPS, and I'm going to show you how to use the QTSPIM simulator to resolve those issues. So without further ado, let's take a look into our QTSPIM simulator. For this demonstration, I'm going to use the example code that I had written in my previous lecture. Specifically, I converted a C code that simply runs a for loop from I is equal to 0 till I is less than 10, and it populates array of I. Essentially, it sets array of I to I. Let me show you the contents of that example code. So I'm going to open up that code. The file is nicely named as example.asm. Now remember that all of your assembly files will need to have that .asm extension. So here's my complete code. And if you notice, I have commented almost each and every line of my code so that if I run into any trouble inside of my code, I am able to use these comments as guide and rectify the issue that has stopped my program from executing. So this is my complete code. First, let me demonstrate to you how to run your complete code in QTSPIM. So I'm going to open up the QTSPIM simulator. So QTSPIM ampersand, in case I need to go back to the terminal and do some other activity. So QTSPIM, okay. So QTSPIM is opened, and I also have my console window that has opened up. Console will be the place where all of your printf statements are going to print, and this is going to be the place where users will enter values to your MIPS code. So should your MIPS code use scanf statements, it's via the console that the user is going to enter their input. For this demonstration, I do not need the console window. So I'll shut it down. The windows that it definitely needs to be active are the register window. So here's your register window, your data segment, and your text segment. I would say that these three windows are one of the most important ones that you should continuously monitor as your program executes. I can also set the format in which the values are printed. Either it can be hexadecimal or binary or decimal. My recommendation is use decimal representation. So data segment is in decimal, so that's great. Register is also in decimal, so that's also great. Next, I'm going to reload and reinitialize my code into the MIPS simulator. Or rather, I would reinitialize my simulator and load the file that I would like to execute. So I'll browse to my target file and I'll load it. Then, in order to run this entire code, I'll hit this run/continue button. So I hit the run/continue button. Notice the text segment of the simulator. Onto your right-hand side, you see the code that you have written. These bolded lines are the code generated by the QTSPIM in lieu of your code that you have written. When I hit run, I notice that my simulator has stopped at this very point right here, syscall. And right before the syscall, I had li$v0, 10. That means my program has exited without any problem. Now this MIPS code was initializing the array to particular or array location to a particular value, specifically array of 0 to 0, array of 1 to 1, and so on and so forth. I should be able to see that. You can see that in the data tab. So hit the data tab, and there you'll see that your array has values populated in them. So I have 0, I have 1, 2, 3, 4, 5, 6, 7, 8, all the way to 9. So that's my perfect execution of my code. Now, let me show you some common errors that oftentimes users run into. And those problems are as follows. Number one is your syntax error. Number two is the program-related errors, which can be they did not compute the offset correctly, or they did not use the base address, or they did not use the base plus offset address correctly, or they ran into some kind of infinite loop. So let me simulate these errors one by one, starting with syntax error. So let me introduce a syntax error inside of my code. So for instance, let's say that I forgot to specify an immediate value to the add instruction. Let's see how the simulator reacts to such a situation. Whenever you make changes to your code, always reinitialize and load the new file. And there you go. Whenever there is a syntax error, the QTSPIM simulator is not going to let you pass. You shall not pass, right? So it is telling you also where the problem is. The problem is in line 15, and I need to go to line 15 and fix that error. So please carefully read the messages that the QTSPIM simulator is giving you. The hint to solve that problem is in those messages. So here it's telling me that there's a syntax error on line 15. So I just need to go to line 15 and find out what the problem is. Specifically, it's telling me that it was expecting a constant value, but it couldn't get it. So I'll abort this code and I'll fix that problem. So I'll fix that problem, 10. Perfect. So this should satisfy that error problem that I got. Now let's look into some common errors that programmers, specifically the beginner programmers, run into with MIPS simulation. Number one, they did not compute the offset correctly should they want to access the arrays. Number two, they did not use the base address correctly. Number three, they did not use the base offset addressing mode correctly. Number four, they ran into some infinite loop. Let me simulate all of these errors, all of these 4 errors one by one, and show you how to use the QTSPIM simulator to solve this issue. Starting with incorrect offset computation. So let me deliberately introduce this error of not calculating the offset correctly. Inside of my code, I am using the S1 counter as my I counter, or S1 register as my I counter. It's set to 0. Then I have my for loop. So here is my proper offset in bytes computation. Now remember, if you have an array of words, then each word is spaced by 4 bytes. So you need to multiply the counter by 4 to compute the proper offset in bytes. So let's say that for some reason I forgot to properly evaluate 4 times I. Instead, I just stopped at 2 times I. Let's see how your simulator is going to behave in such a case. So I will reload and reinitialize. Okay. Now, nothing has gone wrong. So I'll assume that everything is perfect in my code. So let me run it. And there's a problem. It shows you that exception occurred at PC 004-00044. PC stands for the program counter, which points to the address from where the instruction needs to be executed. Now remember, all of your MIPS instructions, they need to be stored in the memory. Those memory will have memory addresses. Program counter holds the memory address of the instruction that the CPU has to execute. So it's telling me here that the CPU was trying to execute an instruction at 004-00044, which broke. Let me press OK to see if there are any other error messages. Now this particular error message right here, unaligned address in store, is telling you that the memory was accessed in a way that it shouldn't have been accessed. There's something fishy going on. Specifically, you are trying to, or your code is trying to access the memory in an unaligned manner, in an incoherent manner. So that's another hint. So it can give you some hints as to what is happening into your code. Most likely, you're not accessing the array locations appropriately. That's the number one hint. Let's zero in to that address location, that instruction address location 004-00044. So this is the address 004-00044, and there I have this instruction store word S1, $0 T1. Now because the problem was pertaining to a memory address, it gives me a hint that something fishy happened when I was trying to access $T1. Now, as your code gets bigger and bigger, you may have to use some other techniques to find out where the problem is. In this trivial code, in this small code, it's clear to me that something bad has happened when I was trying to compute T of 1. So I can just backtrack and see how the T of 1 was computed. So I backtrack all the way here. So T1 is S1 $S1. So that's 2 times I. But I can clearly see here that after this instruction, I attempted to execute target address is equal to base plus offset. So I was adding an incorrect offset value to the base address. So this gives me a direct answer that, hey, you know what? I did not multiply my offset with 4. But as your code gets larger and larger, such backtracking may be slow. It's still your best bet, or still it will definitely work because you are the one who wrote the code. But it's often useful to use simulator given tools to identify such problems. And one of the simulator given tools is the insertion of breakpoints. So let me show you how to insert breakpoint inside of your code, from where you can perform the execution of your code one instruction at a time. And as you perform your execution one instruction at a time, you can observe how your registers are changing. Should they change in a weird way, it gives you a hint as to where the problem is. Or rather, should they change in an unexpected way, it tells you where exactly in your code the problem is. So let me reload and reinitialize this. So I'll reload and reinitialize. And now I'm going to set a breakpoint. I know that the problem occurred at line 0400044. So let me put a breakpoint right before, or much before that, because the preceding code worked without any problem. So let's say that I enter the breakpoint right here. So I'll set breakpoint. So breakpoint is set right here. So when I perform run, my code is going to stop at that location. So the code stopped at that location. Now the QTSPIM simulator is asking me whether I would like to finish the code execution by pressing the continue, or whether I would like to do a single step, or I would like to abort this code altogether. I would perform single step. So single step. Next, in order to keep single stepping, I will hit this single step button. So this is your single step button. So I'll press single step. Okay. So T1 is initially going to be 0. S1 was also 0 because I is equal to 0. T1 is equal to S1 plus S1. So I keep executing. There's no issue in this case because I is equal to 0. So 4 times I is in fact equal to 2 times I. So even the incorrect stuff is right now correct. I jump back to 4. Next, in my next iteration, I counter is set to 1. Now, T1, which is the proper offset in bytes, should be 4. Let's see what happens before this instruction, store word, or rather before computing the base plus offset. So when I hit this one right here, I see that T1 is equal to 2 now, which is incorrect. It should have been 4 because when I is equal to 1, the proper offset in bytes should be equal to 4. But now, even prior to computing my proper offset, I'm attempting to calculate base plus offset. So I compute base plus offset, getting this address right here. And then when I hit single step one more time and try to get a value from this unaligned address, see what's going to happen, what the simulator is going to tell us. It tells us the error occurred there. And what was the error? The error was that we tried to access an unaligned address. So I hit abort and I go back and I fix my problem now. So I'll fix my problem again. So that's problem number 1, or error number 1. We did not compute the base, or rather we did not compute the offset appropriately. Error number 2 is we did not use the proper base address register. Now this error, not using the base address register, may appear frequently if you do not have a nice register map to guide you. Or even when you have a register map, if you do not consult it from time to time, you may run into this problem of using an incorrect register as your base register. So let's say that instead of using S0 as my base register, I, for some reason, just while typing, I used S1. Now let's see what's going to happen and what your QTSPIM simulator is going to show you, or rather how your QTSPIM simulator is going to react. Again, I will reinitialize and load. All of my registers are reset. I hit run, and there you go. It's again telling me that instruction at address so and so 004 it broke. So let's see what the problem was. I said, okay. It tells me that it was a bad address in data or stack. Specifically, it was a bad address in data. Bad address is different than unaligned address. When you have an unaligned address error, like your previous example, you may still be within the array bounds, just that you're not accessing the array in an appropriate manner with an appropriate offset. When you access a memory location which is not allowed to you, you get bad address error. So it's telling me that there was a bad address error at 004 00048 address. So I'll press OK and I'll abort. Abort. So that's the problem. So the problem was right here when I was again trying to access the memory location. Whenever you have error pointed out to such instructions, most likely the way you have computed the base address, T1 in this case, has been incorrect. Let me show you this execution one more time, because stepping into or continuing with this code for a little while gives you a lot of hint as well. So I'll reload, I'll run, it gave me this problem. I said, okay. The problem was my program was trying to access the address 0000. When I press OK, again an exception occurred. Next time I was trying to access this unaligned address 00005. So clearly, such small address values are incorrect. Your addresses are typically very large. So something is happening with your base address in this case. Whenever you see such small values for your addresses, that means your base address is not set properly. You can again insert breakpoints and find out. This particular problem is rather easy to resolve because A, it gives you a hint that you were trying to access a memory location which was computed incorrectly. B, you can understand that it was a problem with the base address because your error was showing that you were trying to access an address which was very small. First it was trying to access the address 0, then it was trying to access the address 5, and so on and so forth. So you can trace back into your code and find out where the problem is. So I go back in my code and see that why T1 gave me a problem. So I'll just backtrack to see how T1 was computed. So T1 was initially an offset, 4 times I, everything was perfect. Now I am doing T1 plus S1. Now remember, S1 was your I counter. T1 is equal to 4i initially, so I'm now doing 4i plus I, which gives me a 5i. That incorrect address of 5 now makes sense because when I is equal to 1, 5 times I is equal to 5. So here's the problem. So I'll fix that. Such problems are easy to occur inside of your MIPS code. You may do everything right, but one teeny tiny error with register usage can break your code just like that, and you may be wondering what happened. So please remember this particular error type, that you did not use the base address properly, how to resolve it. Use your simulator's error messages as hints to find out what the problem was. In this case, we used 2 hints. A, bad address, which tells you that you are trying to access a memory region which is not given to you. B, the error message showed a very small address location or address values, which tells you that you are not using the base address properly. Moving on to the next error, you did not use base plus offset addressing mode at all. So let me introduce that error here, that we did not use base offset addressing mode at all. Now remember, T1 in this case is the address. So you need to use this proper base offset addressing. I have seen this kind of error occurring in my previous students' codes where they would try to load S1 with $T1. Instead of using T1 as a base address, they would use it as a source address. And let's see what happens. So I'll reload and reinitialize. And when I Okay, so something clearly, okay, well, as it turns out, that was a much benign error. It's directly telling me that there was a syntax error. And the syntax error was I was not using the base offset addressing properly. So actually that turned out to be a quite simple error, that I did not use the correct syntax. So I'll just remove this line. That's the correct method. Okay, now moving on to the fourth type of common problem that students oftentimes run into, and that is infinite loop. Infinite loop can be achieved in multiple ways. One of the methods is not to increment your counter I, or not setting the exit condition appropriately. For example, here, this for loop should exit if I is greater than or equal to 0. Then it should exit. If I is greater than or equal to 0, this should exit. If I were to use an incorrect condition here, one of the two things may happen. Either you may run into an infinite loop, or your for loop may not be executed at all. Let me introduce one kind of infinite loop, and that is not to increment the I counter at all. And notice what is going to happen to your simulator. So I'll reload and reinitialize, and I'll hit run. And what I would like for you guys to do is carefully observe the text segment. There you go. See what's happening. Well, if this were to happen inside of your code, even for analyzing large arrays, that means something has gotten wrong. Your program is stuck in an infinite loop. In such a case, what you need to do is carefully notice where exactly or around which lines your simulator is spinning. Those are the lines that are causing the issue. I can see here that my I counter is not incrementing at all. So I will stop this, and I'll go back and fix it. So there you go, guys. So these are some of the common problems that typically arise when students work on labs 10, 11, and 12. Most of the problems are related to the accessing the array values. So please make sure that you compute your offset values appropriately depending on the data type that you're trying to analyze. If you're working with array of words, then you need to multiply the offset by 4. If you're analyzing an array of characters, however, each character is equal to 1 byte, so you do not have to worry about it. Make sure that you understand the base plus offset addressing. Please keep reviewing the lecturettes on the memory fundamentals. Please review the lectures on memory fundamentals and make sure that you understand base offset addressing mode. So that's it, guys. I hope you enjoyed this simulation, and I hope you enjoy coding in MIPS. And should you run into any trouble, please use this video as your guide to solve those problems. For everything else, both Dr. Schaefer and I are just one Slack message away from helping you. So adios, guys.